Okay, so last class we learned all about how we can find missing sides and angles of right triangles. We're going to learn something similar today, but we're going to learn rules that we can use for non-right triangles, since SOHCAHTOA, Pythagorean theorem, all of that stuff only works for right triangles. So we need some other tools for non-right triangles. So the first one we're going to go over is the law of sines, or the sine rule, and it's used in any non-right triangle to find an unknown side or angle, either one. And the information that we need in order to use this is one complete side angle pair. So what a side angle pair is it's when we're given a side and the angle across from it. So that's a pair, C and C. They're across from each other. Another one, angle A, side A, that's a pair because they're across from each other. And then lastly, B and B would be another side angle pair because we have the side and the angle across from it. As long as we have one complete pair and one other piece of information, we can find whatever we want. When you're using your formula packet, it'll look like this right here, but you'll never actually end up having this written out with two equal signs like that. You'll always just have kind of one fraction equaling another fraction. It's just, it has all three to show you it doesn't matter which side angle pair it works. It all works out. It's also fine if you put sine on top and the side on the bottom. That's fine too, as long as you're consistent. You have sine and side, or side and sine, side and sine. That's either way, it's fine. And we will see plenty of examples on the back. But let's write ourselves a little note on the side. What we need to use law of sines is a side angle pair. If we have that, we're good to use sine rule. All right, so cosine rule, we have kind of two different formats of it, and we use one versus the other depending on which information we're trying to find. We could use both for either situation. It'll just be more algebraic solving. But the first one we have, this one, is little c squared equals a squared plus b squared minus 2ab cosine c. If you look at the first part, it looks a lot like the Pythagorean theorem, and that's kind of a helpful connection just because Pythagorean theorem helps us find sides. This first version of cosine rule will help us to find a side. Since this right here, little c, that's a side. So we'll use when trying to find a side. In order to do that, the information we will be given needs to be in the side angle side format. That's what this little blurb of text here is saying, is it's used to find an unknown side in a non-right triangle when side angle side is known. So that, what would it look like? So this one right here would be if we're given a side, another side, and the angle between. That's very specific. Side angle side, the angle has to be between the sides. It can't just be any other angle. It must be sandwiched between the two. And when we do use this formula, it is really important that whatever side we're trying to find, it will be connected to, this right here is going to be its paired angle, so it's opposite pair angle. So this right here is the opposite angle pair. So for example, the triangle I've drawn over here with side angle side, this would help us find A because it is across from the angle in my side angle side situation. We'll see some examples of that soon, but just to lay out what the other one is all about is this one here, big C, that's an angle, so we'll use when trying to find an angle. And the information we need to be given in this case is side, side, side. We need all three sides. So if we are given side, and side, and side, we can find any angle we want. It still matters which side is ABC, like the other one. This here with this little c, those are an opposite pair. So if we wanted, for example, if we want to learn big angle C, we would have to do side A squared plus side B squared minus side C squared. We couldn't do C squared plus B squared minus A squared. It has to be the opposite pair that we're subtracting. All right, so that is cosine rule. And you'll notice this just little note down here. The same rule can be applied to different sides and angles, so it's not just side C we're finding. The C part is just kind of connecting. It can be any opposite pair, any opposite pair. All right. Something that is not necessarily going to be used to help us find missing sides and angles, but will be used in general, is another way to find area of a triangle. So you're probably remembering from geometry, we find the area of a triangle by doing 1/2 base times height. And this is a formula that we'll be able to use even if we don't have base and height. Often it can be a lot of work to calculate the height of a triangle if that's not what we're given. So anytime the info that we're given is side, angle, side, so that was just like above. So if we've got side, angle, side, any side, angle, side, like it could be this right here, that will help us find the area of a triangle. We just have to substitute right in. All right, and then lastly, something that we'll see a lot in word problems is going to be called bearings. So bearings are a way to give measurements. Often they're worked in, they're used in navigational situations, so like ships and planes, things that navigate. So how it works is we have our compass, so north, east, south, and west. The thing I remember to know the order is never eat soggy waffles. That traces us around. So never eat soggy waffles. That's how we can know which goes where. And bearings are going to be measured from north, clockwise. So like this right here, this angle, let's say it's like 30 degrees. It's a 30-degree angle, but its bearing would be 030. So just a slightly different format. I think the reason why you give all three is because computers like consistency, and sometimes angles do have all 3 degrees, like 180 or 350. So having it always be 3 digits, I think, helps computers. All right, so now we're moving on to some examples. The reason we did all that kind of front loading first is just because so much of what's going to be hard with this part of the unit is figuring out when to use what. So we're going to practice here on these next parts, deciding which of the tools we've learned will help us with specific things. All right, so for this first one, always thinking first, okay, what is our goal? Our goal is to find the measure of angle B in the triangle. So angle B, that is this one right here. So when we think, okay, what information do we have right here? Well, we have all 3 sides, but no angles. So the info I have is side, side, side. The info I want is an angle. So if I think, okay, can I use sine rule? Sine rule requires an angle side pair. We do not have any angle side pairs. Yes, there's an angle we're interested in and a side we have, but since we don't know an angle side pair, we can't use sine rule. So this tells us we're going to use cosine rule. And specifically, it's cosine rule where I'm trying to find an angle. So we've got our two cosine rules. I am going to use this one here, that allows me to find an angle. I'll just go ahead and write that formula down so we have it. So we'll be using cosine of our angle. It could be any angle, ABC. They usually use C for this. And it equals a squared plus b squared minus little c squared all over 2ab. So when we think about, okay, what's going to go where, the important thing is if I want angle B here, I'm going to subtract away the side across from B. Since this right here and this right here, those are an opposite pair. So I don't need to go and relabel my triangle or anything. I can just go ahead and set it up. Okay, cosine of angle B, which is what I want, is going to be equal to a squared plus b squared. So the sides, it's touching. So 7 squared plus 14 squared minus 12 squared. So it's very important that the angle we use is we're subtracting the opposite side. A little trick you can use to remember that: the angle is furthest away from its opposite in the formula, and in the triangle it's furthest away from its opposite. And then we'll divide by 2, and then here we use 7 and 14, the adjacent sides again. Okay, now we got to do some calculating. So if you do it all in one go, make sure you use parentheses. You can also just find the top and then divide by the bottom. So I've got the entire top in parentheses and then divided by 2 times 7 times 14, and I get 0.5153 and so on. When I write on my paper, I'll round. I'll say cosine of B equals 0.515. But when I go to solve this by doing cosine inverse, so in B equals cosine inverse of all of that, I'm going to use the exact values from my calculator. So second cosine to get cosine inverse, and then I'm going to go and grab that number. And I get 58.98. So rounding to 3 sig figs, that will be 59.0. And it's an angle, so it's degrees. Okay. All right, I think we're all good there. So moving on to this one. Find the length of side AC in our triangle. So we want this length there. And again, we have to think, what information do we have? We have a side, we have the angle, and then another side. So we have the side angle side situation. We don't have an angle side pair because the only angle I know is attached from a side that I don't know. So again, we're going to have to turn to cosine rule. So if I am going to try to find a side, I'm going to use the version of the cosine rule that looks a lot like the Pythagorean theorem, just with some more added on because we don't have a right triangle. So that will be this version here. So when we're trying to find a side, we're given side angle side, we'll use this one. All right, so that's going to be our C squared equals A squared plus B squared minus 2. Make that a minus and not look like a multiplication. Minus 2AB cosine of big C. And again, we have way far away from the side we're trying to find is the angle that is opposite of it. So for us, we're trying to find B squared. So it'll be B squared equals those two sides that were given, 26 squared plus 18 squared minus 2 times 26 times 18 cosine of our angle 26. All right, so when we're here, we've got to figure out what all that stuff on the left equals. So we have 26 squared plus 18 squared minus 2 times 26 times 18 cosine of 26. You can put all of that stuff through in one long row, just like we see it written out, and we get 158. That is not our final answer, but we have B squared equals 158.728, and so on and so on. I'm gonna now square root each side, and again, rather than using some rounded answer, I'm just gonna go up and get the one I have. To do squared, it's the second x squared button, and then go up and grab that, and we get 12.6, rounding to 3 sig figs. This one here, we don't have any units, so it'll just be 12.6. All right, so if we zoom back out to see what we just did, both of these were examples of the cosine rule. Here, this top one was a side example, and this one was a side angle side example. All right, here, find the area of a triangle below, give our answer to the nearest square meter. So our goal here is to find the area. That means we're probably going to be using that snazzy new area formula we got up here, where we have 1/2 AB sine C. So here we've got area equals 1/2 AB sine of angle C. So that will be 1/2 120 times 240 cosine of 130. So throwing that all in, we get 1/2 120 times 240 cosine of 130, and we get, whoa, yikes, something happened here. Negative 9,000? I'm in degree mode. That's a good sign. Let's see. Oh, hopefully you all got it. I used cosine. We are trying to use sine in this formula. So, hopefully you caught that. We got it now. Sine of 130. 1/2 times 120 times 240 sine of 130. All right, that looks a lot more possible. Areas must be positive, so 11,000 and 31. I'll round it there just because, but if I were rounding to 3 sig figs, it would be just 11,000 because the 3 would round down. And it'll be meters squared. Area is measured in square units. So we're good right there. So through my own mistake here, a good example of especially problems where there's context, like finding area. When you get stuff like negatives, that's a good sign that something is up. Going into our mode to check for radians, that's one thing, and then of course looking at your formulas and seeing if anything happened there. Okay, last little bit here. We've got some more triangles where we're trying to find the missing pieces of information. They're non-right triangles, so we know SOHCAHTOA and Pythagorean theorem are ruled out, but let's see what info we are given here. We have two sides and an angle. The angle is not between the sides, so it's not going to be a side angle side cosine rule situation. But I do have a angle side pair that are right across from one another. So that is my clue that I am going to use sine rule. So sine rule, we're always going to stack our angle side pairs here that we've got. The way it'll look in your formula packet will be something like that, where we've got our sides and then our angles with sine on the bottom. So it'll be, let's see, if we've got A over sine A equals B over sine B. The angle side pair we have is S right here. So we're looking for 15 over sine of 125 is equal to the side of 6.5 over sine of Q. Since we're trying to find angle Q here, that is going to be our unknown, and we have side 6.5. Just a note, if we had been asked to find angle R, we might be worried at first because we have a side angle pair, but we don't have the pair across from R. We could still find angle R. We would just have to find it through finding angle Q, and then we'd use the fact that all three angles add up to 180 degrees. So even if the info you're trying to find doesn't have a side angle pair, as long as we have one known side angle pair, we can find the other angles. We just might have to find the one we have enough info to find first. But luckily, in this case, the angle we want is part of a side angle pair, so we can go ahead and use it. All right. So if we're going ahead and solving this, when we've got fractions equaling fractions, we are in a good position to cross multiply to get to our next step. So I'll go on up here. So we've got, it'll be 15 sine of Q is equal to 6.5 sine of 125. And then to get Q all by itself, I'm going to divide each side by 15. So I'll get sine of Q equals all of that stuff. At this point, we could go ahead and find out what actually is all that stuff. So if I do 6.5 sine of 125 divided by 15, I get all that. So sine of Q is equal to 0.3549 ... It keeps going. I'm going to find Q by taking the sine inverse of that, and again, not using a rounded value, using the value that's still sitting in my calculator. So sine inverse of 0.35... Oh, what am I doing? I'm doing exactly what I told you all not to do. Sine of all of that. There we go. So Q equals, when we round, 20.8 degrees. All right, there we go. And then just a small reminder, if you are working with a NumWorks calculator, when you are calculating sine inverse and stuff, it's going to say arcsine. It means the exact same thing. The answer will be the exact same thing as what we've got in TI land. Okay. So, last problem here, we're trying to find the length of side AB. So this right there is what we're trying to find. What info are we given? We have a side angle pair, and we have half of another side angle pair. If we didn't have this angle, but we had this one, we could get this one easily because all three would add up to 180. But we're in luck, we have a side angle pair. So when I set up my sine rule with my pair that I have and the half pair that I'm looking for, we've got 15 over sine of 70 equals x over sine 45. Again, I can cross multiply these and I end up with 15 sine of 45 equals x sine 70, and then I will divide each side by sine 70. So x will end up being 15 sine 45 divided by 70. And then when I go to calculate this, 15 sine of 45 divided by 70, I get 0.513. Oh, is that, let's see. Oh, I forgot to divide by sine of 70. Today is one of those days. Lots of little things. Let's try that again. So, make sure you fix it in your notes. We're dividing by the sine of 70. So, we have 15 sine of 45 divided by sine of 70. That looks a lot more like it. X equals 11.3. Again, we don't have units, so we'll just leave it like there. So again, especially when we have geometry things, we can do things like second guess when we get an answer like that was less than 1, for example, and this triangle didn't seem very realistic given the information that we've got. One thing to note is the larger the side, the larger angle that's come across from it. So I know that 70 and 15 will be the longest side, 45 will be smaller, but generally it's not going to be so small, like less than 1, since 45 isn't that different than 70, and the relationship between angles and sides is somewhat proportional with all of the sine stuff. All right. That is all for today. We'll just make a little note that these were our sine rule examples, and we will do some practice in class. Okay. All right, how do I get out of here?